For this problem, we're going to focus more on the conceptual side of the work-energy theorem. Here we have two ice boats, one of mass m and one of mass 2m, hold a race on a frictionless horizontal frozen lake. Both ice boats start at rest, and the wind exerts the same constant force, F, on both ice boats. And we are asked to solve for which ice boat crosses the finish line with more kinetic energy, and which ice boat crosses the finish line with a higher speed. Before we start solving, let's label the ice boat with the smaller mass, A, and let's label the other one, B. According to the work-energy theorem, the net work is equal to the final kinetic energy minus the initial kinetic energy. And we also know from previous videos that the net work is equal to the net force times the displacement of an object. So using both of these equations, we can write the equation, the net force times the displacement of an object is equal to the final kinetic energy minus the initial kinetic energy. With this equation, we can now solve for both ice boat A and ice boat B's final kinetic energy. So for ice boat A, we have that its net force times its displacement is equal to its final kinetic energy minus its initial kinetic energy. And for ice boat B, we have its net force times its displacement is equal to its final kinetic energy minus its initial kinetic energy. Now you may be wondering why I did not denote the force and displacement for each corresponding ice boat. The reason I did not do so is because the problem tells us that each ice boat receives the same constant force and experiences the same displacement. So now that we have both equations, we can cancel out the initial kinetic energy term because the problem tells us that both ice boats start at rest. So ice boat A will have an initial kinetic energy of 0. And ice boat B, oh wait, I forgot an I here. So yes, ice boat B will also have an initial kinetic energy of 0. And since both ice boats experience the same net force and displacement, we can set both equations for ice boat A and ice boat B equal to each other. So we will have the final kinetic energy of ice boat A equal to the final kinetic energy of ice boat B. So the answer to part A is that both ice boats will have the same final kinetic energy. Now let's solve for part B. So we have to figure out which ice boat will cross the finish line with a greater speed. To solve this, we can use our final answer in part A. We said that the kinetic energy for the final kinetic energy of ice boat A is equal to the final kinetic energy of isotope B. So using the kinetic energy formula, let's expand this equation. So the final kinetic energy of isotope A is going to be 1/2 m times the final velocity of isotope A squared. And that is going to be equal to the final kinetic energy of isotope B, which is going to be 1/2 2 times m times the final velocity of isotope B squared. And the reason it is 2m is because the problem states that isotope B has a mass of 2m. So now we can cancel out the 1/2 m terms on both sides to leave us with the final velocity of isotope A squared is equal to 2 times the final velocity of isotope B squared. This means that isotope A will cross the finish line with a greater speed than isotope B, precisely twice its speed. So we can write down that isotope A has a greater final speed than isotope B. With that, this concludes this two-part video. I hope you have a stronger understanding about the work-energy theorem and are able to use this theorem to solve some physics problems.